Right, so when you run Beast, it generates some particular output files. So the output files it generates are a log file, and the XML file is the output of Beauty. It's the actual file that it runs. Then it's got a state file, which is where it saves the current position of the simulation that it's doing. Then it's got the and it should have, as well as this, some trees files, which are these things down here. No, here. So the tree files are all related, they all have a name related to the file that was used to set them up. Now, first thing I want to do, because we're looking at most recent common ancestors, is run tracer. So this is another program that you actually have to get from the Beast One website, or actually you might get from Git, or GitHub, which is a software download space. So what this allows you to do is look at these log files. So if I look at it with Notepad++, it's not particular. So what I can do is do File and Import Trace File. This is painfully slow today. That would be, no, that's fine. So this a PC on file system D, and we go for downloads and we go for bioinformatics session. Now I've got all these different log files. So I've got the first one that I ran of a speculative simulation, and then I've got the ones that I did thinking about it. So I'll show you the ones that I did thinking about it first. So this is the first one that I opened. Hello, computer. So when you open up the trace file, it starts in this column labelled the posterior. This is posterior probability. You don't have to particularly worry about it. So the most recent common ancestor is the height of the tree. So what I want to do is click on the thing that says height of the tree, and it gives me this. So it says that the mean is 1553, the median is 1546. So let's stick with the median one, because that doesn't look very normally distributed to me. So we'll use the median. So the median is 1546 days before the final sample. That's the first simulation. Now the reason why this simulation is not terribly good is because I've got these red things here. So this tells you how well the model has sampled each of these things, and the values need to not be red or not yellow, and they need to be black, so above 100. So this is telling me the simulation didn't work very well. But the most recent common answer is 1546 days, and it's going to be somewhere between the 95% highest probability interval is between 1304 to 1827. So somewhere in that range you're going to see the correct age for the common ancestors. So let's open another trace file. So let's take the second one that I tried to do, where I hoped I'd get better results, and I've still got loads of red things. But this one gives me an answer of 1551 days, 1544 days is the median. 95% HPD of 1298, 1299 actually, to 1823. So that's like, these HPDs are like confidence intervals, only they actually mean what you expect them to mean. It means there's a 95% chance that the most recent common ancestor is between those two ages. If I do the third one, I've got a yellow one here, but I've still got red ones down here. The tree height, the median is 1543, and it goes between 1294 and 1819. So that was is that the third one? This is the fourth one. Still, I've got red things and I shouldn't have. So for the fourth one, the median is 1552 days. That's weird. And its range goes between 1307 and 1833. Done. Now I'm going to import the last trace file, which was from the initial file I created without doing any thinking about things. If I open this one, what? Okay, they're also all bad. That's annoying. So this one is median 1535, but this one's got lots of lower values than I want, so I don't like that one. So I'm going to import another trace file, which is from the directory called runs, which had the original ones, and I'm going to run this updated one and press OK. Now that is what an output file should look like. It should all be in black, so there shouldn't be any particular problem with it. There should be no reds, nothing that's a problem highlighted, so it all should be nice and sorted. So in this case it comes out as the tree height, giving a median one, is 1543. And it goes between 1304 and 1834. So in general, the median ages to the most recent common ancestors were 1546, 1544, 1543, 1552, 1543. So they're all about the same. The difference is 9 days between the shortest and the longest. So you're talking about 1540 days. What is that in years? So that's 4.2 years. Now what I was expecting is that if you got an outbreak, the originating event which created it would happen quite close to the outbreak itself. So with COVID, we first detected there were examples of COVID, and we had the first 100 cases that we detected in 2019. So in November, December 2019. And by March 2020, so you're talking about 4 or 5 months later, the pandemic had got hold sufficiently that we couldn't control it, and it was going to end up being a pandemic and global across the world. So what puzzles me is, if we got a sudden outbreak of bird flu, like we did here, why did the originating event come from so far in the past? So it looks to me like I've made a bit of a mess up in the data that I've collected. So it looks to me like at the site where you collected the data from the outbreak, you have sequences which are from the outbreak. But you also have another set of sequences which are not part of the outbreak but happen to be there at the same time, which is a bit inconvenient, to put it mildly. So what we can try and do is have a little look at the tree, so the phylogenetic tree from this particular set of data. Now when you look at phylogenetic trees from phylogenetic trees which come from beast, they're a bit more complicated than the usual ones. So I'm going to close Tracer and I'm going to go back here and I'm going to use, out of the beast directory, a program called Treeannotator. So what Treeannotator does is it takes the file which has lots and lots of trees created by the simulation, it merges them together to a single tree, and it calculates a posterior probability, which is the same as the bootstrap, based on the probability of seeing those two leaves beside each other in the tree in all the trees that were produced. So the first thing I need to do is choose the file that I'm going for, which will be in file system D, downloads, bioinformatics sessions. Which tree do I want? Actually, which is the most recent? That's aligned, edited, updated. These are all the same. Which one's the one that I want? Which date did I create them? What's the date today? The 13th. So let's get the most recent one. So that's this one. So I open that tree file. I then need to give it an output name for the tree file, which I'm going to put into, I'm going to call it MRCA H5N8, and I'm going to call it the finalized tree. Save that. Now the other thing I need to do here is click on the low memory button, otherwise it crashes horrendously. And the other thing I want is the median heights of each of the nodes. Just reselect that. You can pick what percentage of the simulations you want to get rid of and not do the calculation from, and then you press run. Now this will take a little while to merge together all those particular trees. So the tree file contains 18,001 trees after removing the first 2,000. That doesn't look quite right to me. 2,000, okay, yeah, it is fine, because there's 20,000 trees. That's fine. So it's combining those 1,801 trees together to make the most credible tree, which is the one which has all of the connections that are seen most often in all of the trees that it's got. Once it's done that, you can work out the probability of each of the connections that it's got. So sometimes you might see a connection in every single one of the trees that you've got, and sometimes you might not. Right. So it's telling me there are 53,024 clades. So there are 53,024 different ways of sticking this data together into groups and clusters, which is quite a lot. So it's quite a complicated analysis. Right, done the second stage. So it's now doing the annotations of the tree. Once it gets to the end of this, I can just close down this. Okay, it's finished. So it doesn't stop the program automatically. You just have to close it and drop out of it. So now I've got the tree created, the merged together tree. I can use FigTree to view it. So here's FigTree. Oops, I've clicked it too many times. It's now going to open it loads of times, which I don't want. Right. File, open. What's it looking at that? So what I want is the MRCA most recent common ancestor H5N8 finalized tree. Open. And it looks like this. Now, when I put the data for the tree in, I put the ages of each of the nodes dependent on days. So that's what this scale bit thing means at the bottom. I don't particularly want the scale bar, but I do quite fancy having a scale axis. I fancy having a scale axis without a grid on it, because having the grid on it is a bit annoying. And I want to reverse the axis. So that means 0 is the most recent sequence that's been collected, and you can read off the most recent common ancestor because it's this vertical line here. So this is the split between the ancestor and when it's split into two groups. So the most recent common ancestor of this group and this group occurs here, in this time point here, which is minus 1,500 and something years ago. Days ago, sorry, not years. This is a bit difficult to look at. So another thing you want to do is not use zoom. Well, I can show you what happens if you use zoom. It just zooms completely. Everything gets scaled, and it just makes it really hard to go around the tree because you have to move around, and no, that's just not useful. So zoom's not a useful function. What's more useful is expansion. So what that does is it just expands it along the y-axis. So once it's expanded it enough, I can actually start to read the text, which is what I want. So I can see different groups. Now the length you've got along these lines is how many days it is. So here is a recent, probably the most recent of the files, which was collected on the 25th of the 5th, 2017. So I have to go back however many days this length is until it's split from the ancestor, which corresponded to the sequence that was collected on the 5th of the 1st, 2017, and the 23rd of the 1st on 2017. So those two were divided from it, and it's got to be quite a few days ago because that's before January 2017. So it's got to be sometime in 2016. So it's got to be more than 5 months old. So this is going to be about 6 months, or more than 6 months. So you can work out all of the times for all of the splits between all of the sequences. Now, the reason why this evolutionary time is way bigger than I expected is because we've got this cluster of sequences down here, which are quite different to all the others. So for those of you doing clades, because this is an H5 thing, this is the 2.2.3.4 A and B, sorry, and 2.3.4 B, C. So it's B and C. Anyway, it's two different clades that were divided from each other about 5 years ago, 4.5 years ago. So that's what I said when I think I've contaminated the new outbreak, which is all from within this clade, with some existing cases which come from this other clade. So what I did in the bioinformatics sessions is I created some more for the different clades. So I created a separate FASTA file for 2.3.4.4b and 2.3.4.4c. So now I have two separate files. I'm going to align that. So while these 5N8s, and they were collected during the period where we had the H5N8 outbreak, I don't think they're part of that H5N8 outbreak. They're part of something else. Either that or the H5N8 was created multiple times. So this also relates to the people who are doing the relationship between H5 and preferences for different N types. Because this tells you that H5N8 was not created once, it was created at least twice and possibly more times even than that. And the other ones are all the B clade. Now I've separated them out, I'm going to redo all the trees in this one. Right. So, what else? That caused me to change what I decided to do. Where's the FigTree? So the other thing I wanted to show you about FigTree is how to make it so that it's usable and readable. So for example, if I want to take out this clade at the bottom here, so what I can do is click on the clade thing, the clade term here, and because I've clicked there it picks all of this unit. Then I can do Control C and I do File, and New, and I can do Control V, and I just have the tree part containing this. I don't have all the rest of it. So when you've got very big and complicated trees, what you want to do is pick out bits that have different pieces of information and cut them and paste them into new files, and then do the analysis of those files. So now I've got this smaller file, let me show you how to make it look good. So first thing, get rid of the scale bar, put on the scale axis because we want that. Reverse the scale axis so it starts at 0. Get rid of showing the grid because otherwise it's too cluttered. Now you have the names of each of those sequences at the end of the tips. The font's not very good, or the font size is not very good, so let's change the font size. Do you like that font? Personally, once it gets above size 11 it doesn't look very good. But you can change the font to whatever one you like. So at the minute it's 18th century Gothic or whatever. You can change it to... I'm going to change it to Comic Sans just because I'm being funny. So you can change it to Comic Sans. That's terrible. That's really awful to read. Let's not change it to Comic Sans. Is there another Comic Sans? No. What do we fancy changing it to? Times New Roman, I suppose. What the hell's Cracked Johnny? Definitely we're not doing that. So there's Tolkien. I want Times New Roman. Right, Times New Roman. Okay. That's not bad, I suppose, but still, I don't find it that nice. Right. So I can change the font in size. I could change significant digits if I had any, but I don't. And this. The other thing you can do is add shapes on the tips. So I can click on tip shapes and I can add them as circles, or I can add them as rectangles. Well, they're not like squares to me. Or I can add them as diamonds. Probably circles is the most appealing. That makes it slightly easier to look at. So these are the tips or the branches. The internal things here are called the nodes. So I can also add node shapes. So if I can have node shapes and they're a circle, and I can colour them by particular things, but I can just leave them as is. And I can label each of these points. So a useful label is usually, in the node labels, to label them by the bootstrap value, which in this case is the posterior. So I can put the posteriors on it. They're a bit too small, so I can't read them. That's a bit better, so I can read them. So unlike the bootstrap, which is in percentages, these ones are in probabilities between 0 and 1. So this is bootstrap value of 100, 100, 100, 100, 100, 99, 99, 25. Oh, and I can get rid of so many decimal places because it's too many. So node labels, let's get it down to just 2 figures, that's fine. So this one's got an 87%, 13%, 14%, 82%, 99%, 100%, 100%, 100%, 34, 80, 25, 99, and so on. Some people say that if your bootstrap is below 60 you can't believe in it, but that's some people who don't understand how this works. So as I said, I've made 20,000 trees. What I've done is brought them all together to make a tree where all the things that are in common, where you merge it all together to see which parts of the tree, so which things are beside each other in all of the trees. So these two things are beside each other in every single one of those 28,000 trees. And these two are beside a group which contains all of this lot in all of the trees. But only in 13% of the trees do you get this group beside this group. So sometimes there's ones that move around between the different groups. And it's not going to be these because they're 100%, or these, which are all high percentages. So it just means that this thing, sometimes it's here and sometimes it's here, attached to this one. This sequence is causing a problem. So 14% of the 28,000 of them, this one is here. 13% of the time, then you get it like this. And another amount of the time, then this thing could be attached to one of these, or here, or here. Actually, it can't be there because they're all one. Well, it could be. It could be branched off here, it could be branched off here, it could be branched off here, 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 here. There's lots of different places where this particular sequence can be. But most often, it's seen here. But that's still only 14% of all the different ways that you create it. The only thing you need to keep in mind is this is a problem. This sequence is a bit weird. Otherwise, you don't need to think about it at all. And here, this 34%, this is to do with this one being a problem as well. So usually you find it when you've got single ones out on their own, they're not easy to place them in the tree. So that's all good. Now, the question that the person had to answer was about most recent common ancestor. So to do that, you've got the length of this. So I can just read it off this the bottom axis if I want to. So I can read this to say that that's minus 1,250 days. It's just a bit short of that. But I can get the exact values. Now remember, I had the confidence intervals, these HPDs, probability distributions. So what I can do is display those confidence intervals instead of just picking an age. So that's called a node bar. So once I put the node bars on, I can specify what they are, and it's going to be the height of the 95% HPD. So this shows that while this is the average time to the most recent common ancestor, it can be anywhere between these two dates. And similarly, the split between these two can be anywhere between these two dates, and these ones between these dates, and these ones between these dates. So if you imagine sliding a ruler across and you look at a vertical straight line, this is why you see, so you see 100% when there's no overlapping between the line you've got here, which splits these two, and the line you've got here, which splits this one from these two. So there's no confusion as to the order that these three sequences split from each other. So you get high probabilities here and very clear separation. Same here, it's a bit lower because there's a possibility of this one being in a slightly different place, but most of the time it isn't. But where you've got areas where there's lots of overlap, so here, 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 and these two, and this one, this is when the probabilities start to drop off, because you can't tell exactly when that branch happened. So if that splitting happens there, or did it happen here? In which case the order's changed and the probabilities are changed. This is also very important when you're looking at the most recent common ancestor, because it's not enough to just say, oh look, the most recent common ancestor is here, it's exactly this point, I read it off the graph. It isn't, because it could be anywhere in this distance, which is why I looked at the tracer output before I looked at the tree output to show you what it actually meant.